Lecture in Ahle High School and the Junior College. Welcome to a series of the lectures of Intermediate First Year Maths A. We discussed the different chapters of first year. That is, we did mathematical induction, matrices, and all parts of trigonometry. Right? Today we are going to start a new chapter, that is functions. What is a function? It is just an English word. Right? Just try to understand the meaning. That is, a function does some work, that is, it processes the input and gives an output. Okay, when it comes under a block, let us say there is a block. If I give some input x, it gives an output y, then there is some function done inside. Okay, yes or no? That is, it is represented in the form of function of x, then the output will be y. Clear? Is it right? Then what are these inputs, what are these outputs, and what kind of function it is? We'll all discuss it in detail. Clear? You understand? Simple. There is a simple understanding. Okay? A function is a process in which the inputs are processed to give an output. Right? Is it clear? Fine. Before going into the technical terms of functions, let us have a few basic introductions about sets, relations, and everything. Hope you all know what is a set. A set is a set of elements, whether it is alphabet or numbers or some other. Okay, set is a group of elements. Okay, in which each and every element belongs to a same group. For example, if I say set of even numbers, then I will have even numbers of a limited range, or it might be an infinite range. Clear? Based on that, we will define it as finite set or infinite set, and those all you have a brief idea, right? Similarly, with the continuation of set, we will discuss what is a relation. Okay? What is a relation? A relation is a simple relation or some kind of common thing between the two sets. Let us see what is it. For example, if I say some set A and set B, and from set to set B there is some kind of relation, which means if I add plus 3, then I may get the number of this set. Okay. For example, if there is an element 1, then what is the relation? If I add 3, I will get the element of this set. Is it clear? We learned those kind of 1-1 relation, 1 to, okay, 1 by 2, I mean 1 to many, many to 1, or many to many, those kind of relations we know. Clear? Is it fine? Good. Then how do we represent a relation? Tell me. A relation is always given as A to B, which is this is the first set and this is the second set. Clear? That is, this can be have one way and this can have another. We will discuss all those when it become to discussion of function. Clear? Next, what is this Cartesian product? You people know. That is, if I say A is equal to 1, 2, 3 and B is equal to A comma B. Okay. Then if I want to combine both, then I will get Cartesian product is given by A cross B. Okay. That is given by 1A, 1B, 2A, 2B, and the next 3A and 3B. Isn't it? For example, if I say 1, 2, 3, A and B, then I will have 1A, 1B, 2A, 2B, 3A, 3B. These are different relations of A and B. Okay, we can even discuss about this cardinal number. What is cardinal number? Number of elements in A is called as cardinal number. How many are there? 3, and here n of B is 2. Then what about n of A cross B? N of A cross B will be product of n of A into n of B, that is 3 2s are 6. Is it clear? Fine. These are the basic discussions about what is a relation and everything. Then what is a function? How do we define a function? Just remember, a function is said to be a relation from A to B, where A is a set, B is a set. Okay. A function is defined as a relation from A to B that each and every element in A should have at least one output in B. Okay, what is this A and B called as? A is called as domain and B is called as codomain. Is it clear? And we can also call the element in codomain is called as image and the element in domain is called as pre-image. Is it clear? That is, a function is a relation in which each and every element of A should have at least one image in B. Is it clear? Which means A should not be empty. For example, can I tell this as a function? Yes, we can say, because all the elements of A are filled. If I say there is one more number 4, can I tell this as a function? No. Why? Because there is one more element extra in this domain. Clear? Did you understand? The first part is domain and the second set is codomain. Is it right? Yes. That is, a function is represented as y is equal to f of x, where x are inputs, or it is can be called as set of pre-images. Okay, whereas y is the output, or it is nothing but set of images. It can be called as a range. Range is nothing but set of images. Clear? Hope you all understood the basic things. We are going to use this terminology. Clear? Did you understand? Fine. Shall we move on to the types of functions? Let's do. See here, there are many types of functions based on the application, based on the subject which we use. Okay, but broadly we can classify into the types which we are going to discuss, that too only mathematically. Again, based on the applications. For example, if I say trigonometry concept, then those are called as trigonometric functions. Those are also functions. Okay, but again they can be segregated into our mathematical things. Clear? That is, let us have a deep discussion. The popular type and the first type is 1-1 function, or it is also called as injection. What is this 1-1 is? We discussed two sets, set A, set B. Then f is a function from A to B. Clear? What are elements in A called as? These are called as pre-images. Remember, pre-images of A and images in B. Clear? Now just remember, each and every pre-image of A should have unique pre-image, unique image in B. Okay, once again let me tell, every pre-image in A should have unique image in B. In technical terms we can remember like this: for every A belongs to A has unique image B belongs to B. Okay, which means for every one input you have to get only one output. Is it right? That is 1-1 function. 1-1 function is for every single input you have to get single unique output. Clear? This output should not repeat. Okay, is it clear? Fine. Shall I give you an example? Let us see here. F of x is equal to x plus 5. Tell me, it is a 1-1 function. How do we tell? That is, whatever the number it is, whether it is 0, 1, 2, 3 and everything, for all the numbers, for f r to r, r is a set of real numbers, domain is a set of real numbers, codomain is also a set of real numbers. So, for whatever the numbers we add, just I will get a number plus 5. Clear? Fine. Next, let me give you one more example. F of x is equal to x square. Is it a 1-1 function? Tell me. No. Why? Because if it is for 0, 1, 2, 3 I will get the outputs as 0, 1, 4, 9 and so on. Yes, they are unique for every input. Then what if I have numbers -1, -2, -3? Here also you will get 1, 4, 9 and so on. Isn't it? Yes or no? Which means the outputs are repeating from -infinity to +infinity. What if I say the input is a set of only whole numbers? If I remove these numbers, can I say this as a 1, 1? Yes, right. Therefore, the function domain must be whole numbers to real numbers. Okay. This should be only whole number set. That is, it should start from 0. Before 0, it is not valid as an injection. Is it clear? Do you understand the theory about the 1, 1 function? Fine. Let us move on to the next function, that is onto function. Onto function, or it can also be called as surjection. Okay, what is this onto function is, this is not a 1, 1 function, but it tells that if I have a 2 sets A, B, then it tells that for each and every image of B should have at least one pre-image. Once again, let me tell, for any image of B should have at least one pre-image in A. Clear? That is, for every image in B, that is B belongs to B, should have at least one pre-image in A, that is A belongs to A. Is it clear? Which means we should not have any empty element in B. Just try to understand. If I want to define a function, then I told that we should not have any element left in A, right? If I want to tell it as a pure onto function, then I should tell that there should not be any element left in B. Clear? Which means if you observe in surjection, A and B, each and every element is filled. That is, all the elements are used up, our inputs are outputs. Clear? Fine. And one more thing can I tell in this onto function is, if you observe, what is a range? Range is a set of all images, right? What is codomain? Codomain is a set of all these elements in B. Clear? Then if I define a range, range may not be equal to codomain, but if it is in surjection, range should be equal to codomain. What is the condition for surjection? Range should be equal to codomain. Clear? Is it fine? Did you understand? These are basic types of function, that is 1, 1 and onto. Shall we move on to the next thing? See here, one more thing, and the very important thing is bijection. What is a bijection? A bijection is a type of function if it is said to be a 1, 1 and surjection. Clear? Did you understand? A function is said to be bijection if it is both 1, 1 and onto. Is it clear? What all functions we learned? 1, 1, onto and bijection. Clear? Next, and one more function is inverse function. Before learning that, remember, whenever a function is bijection, then we can tell that their inverse exists. Okay, for example, if I say sin x, f of x is equal to sin x. Yes, it is a 1, 1 function. It is also a onto function. Therefore, it is a bijection. Therefore, that's why there is a function called sin inverse exists. Clear? Sin inverse is not just 1 by sin. It is a sin inverse itself is a function. Is it clear? That is nothing but f inverse x, which is sine inverse x, it always exists because sine x is a bijection. Is it clear? Did you understand? If a function is bijection, then its inverse exists. Clear? Fine. Other than them, one more thing is constant function, identity function and composite function. What are those is, a constant function always gives an image as a constant. Is it clear? A constant function gives a fixed image, that is a constant image. The popular example for this is simple, f of x is 5. Okay? The output or the function, it is not in terms of x. So, whatever you substitute as an x, you will get a fixed value of 5. Clear? Is it right? That is called as a constant function. Clear? And next, the one more function which we are going to discuss is an identity function. What is this identity function? Just tell me. Identity function is a type of function in which the value of pre-image is equal to the image. Okay. For example, if I substitute 5, then I will get the value as 5. Okay. If I substitute 4, the output I will get it as 4. Clear? That is, it is popularly denoted by IA. That is, it maps from A to A. Clear? Is that right? Yes or no? What all functions we discussed? 1 function, onto function, bijection, inverse function, and the next constant function, and finally identity function. Clear? These are two basic functions. Based on this, we can have many more functions ka definitions. Clear? Did you understand? Shall we move to the next concept? Let's do. The next type of function we are going to learn is composite. What is this composite function? That is, by the time we can tell that it is kind of mixture. That is, if f of x is a function, g of x is a function. Let us say f maps from A to B and g maps from B to C. Okay, that is, f is a function that maps from A to B, okay, and g maps from function B to C. Then the composite maps from A to C is g of f. Okay, that is, g of f is a composite of a function that maps from A to C. That is g of f, g circle f of x, that is simply called as, okay, that is represented as g of f of x. Is it fine? Did you understand? That is, g circle f is a composite of f and g. Clear? That is, it goes in the opposite direction. Clear? Don't write as f of g. Both are different. F circles is different from g circle f. Clear? Shall we do problems? Let's do it. Here the question is given as f of x as x plus 2 for x greater than 1. Okay? For equal to 2, for it, if it is lies between minus 1 to 1. If it is x minus 1, if it is minus 3 to minus 1. So they are asking us to find the values of f of 0, minus 1.5 and minus 5. Okay? Now check here, f of 0. 0 lies from minus 1 to 1. So f of x ka value is directly 2. There is nothing to substitute. Therefore answer is 2. Okay. Next, minus 1.5. Minus 1.5 is less than minus 1. That is here. Is it clear? Therefore it is x minus 1, that is minus 1.5 minus 1, that is minus 2.5. Is it fine? See here. Minus 5. Less than minus 5. Is there any value? This is minus 3 to minus 1. This is minus 1 to minus 1. This is x greater than 1. Then what about f of minus 5? Tell me. It is not defined. Therefore, there is no value for minus 5. Then how do we define it? Isn't it? Clear? Fine. These are all the basic definitions, types of functions and a basic example of function. Clear? There are many more problems to solve in this chapter. Let us meet in the next session with the more problems of functions. Thank you.